Imagine a night sky lit by streaks of fire and bursts of color. This was the scene in ancient China where rockets were born. These weren't the soaring spacecraft we know today. They were simple tubes filled with gunpowder, more spectacle than science. But these early fireworks held within them the seeds of a powerful technology. The Chinese called them fire arrows. These arrows, propelled by the explosive force of gunpowder, marked the beginning of our journey into the cosmos. From these humble beginnings, rockets would evolve over centuries. Their potential for both war and peace became increasingly clear. The principles behind these early rockets were straightforward. Gunpowder, when ignited, rapidly produces a large volume of hot gas. This gas, confined within the rocket body, seeks an escape route. It finds that escape through the rocket's nozzle, creating thrust. This thrust propels the rocket forward, leaving a trail of fire and smoke in its wake. The invention of rockets marked a pivotal moment in human history. It was a testament to our ingenuity and our desire to reach beyond our grasp. Little did the ancient Chinese know that their invention would one day carry us to the stars. Centuries passed, and rockets transitioned from festive displays to instruments of war. During the 19th century, rockets like the Congreve rocket emerged. These rockets, significantly more powerful than their predecessors, terrified enemies on battlefields. The age of rocket-powered warfare had begun. World War II saw the terrifying power of rockets unleashed on a massive scale. The German V-2 rocket, a technological marvel of its time, rained destruction from the skies. This weapon, a precursor to modern ballistic missiles, showcased the immense power of rocket technology. The V-2 rocket, however, was more than a weapon of war. It represented a significant leap forward in rocketry. It utilized liquid-fueled engines and sophisticated guidance systems. These advancements laid the groundwork for the rockets that would later breach the bonds of Earth's gravity. The horrors of war, unfortunately, often serve as crucibles for technological advancement. The development of rockets during this era is a stark reminder of this fact. Yet, from the ashes of conflict, the dream of space exploration began to take shape. The aftermath of World War II saw a new conflict emerge: the space race. The United States and the Soviet Union, locked in a Cold War rivalry, competed for dominance in space. Rockets became the ultimate symbol of technological prowess and national pride. The Soviets struck first. In 1957, they launched Sputnik, the first artificial satellite, into orbit. This event sent shockwaves around the world and ignited the race to explore space. The United States responded with Explorer 1, its own satellite, in 1958. The space race was in full swing. The ultimate prize in this competition was the moon. In 1969, the United States achieved a stunning victory with the Apollo 11 mission. Neil Armstrong's famous words, "That's one small step for a man, one giant leap for mankind," marked a pivotal moment in human history. The space race led to an unprecedented acceleration in rocket technology. It pushed engineers and scientists to their limits, resulting in the development of powerful launch vehicles like the Saturn V rocket. This era of exploration forever changed our understanding of our place in the cosmos. Rockets might seem incredibly complex, but the basic principles behind their operation are surprisingly simple. It all boils down to Newton's third law of motion. For every action, there is an equal and opposite reaction. Imagine a balloon filled with air. When you release the balloon's opening, the air rushes out, propelling the balloon in the opposite direction. Rockets work in a similar way, but instead of air, they expel hot gas produced by burning fuel. This expulsion of hot gas creates thrust, the force that propels the rocket upward. The amount of thrust generated depends on the mass of the gas expelled and the speed at which it exits the rocket's nozzle. This is where the rocket equation, developed by pioneers like Konstantin Tsiolkovsky, comes into play. To escape Earth's gravitational pull, a rocket needs to achieve a speed known as escape velocity. This velocity, approximately 7 miles per second, allows the rocket to break free from Earth's gravitational grip and venture into space. Achieving this velocity requires immense power, meticulous engineering, and a deep understanding of the laws of physics.